Modeling growth with other bases. Sometimes the exponential function e to the x is not a very good approximation for the growth of a certain population. So this is where this next formula comes in kind of handy. Y equals y naught times b, which is our base, to the power of t divided by n. And this is where n is the amount of time until y naught times b is the desired growth. So what this means is n is 5 years, 30 days, whatever the problem tells you. In this next example, I'm going to show you how to identify when you know you need to use a different base rather than our e to the kt formulas. So example 5. On day 1, a population of wasps growing at a rate proportional to the population is 10. So on day 1, population is 10. This is a good thing to note. I would underline that. Note, this is our initial value of y naught. The number grows to 50 in 30 days. So it reaches 50 wasps in 30 days. And 50 will be our total. So this is going to be y of 30, and this is going to be n. How many days later will the population be 100? So what I want to know is how many days after the 30 days will it take for the population to go from 50 to 100. So essentially, I want to double the population. And your instinct might say, oh, well, it took 30 days to go from 10 to 50, so 20 days to add 40 wasps. So by that logic, I just need to add 40 and then another 10, so it's going to be about another 30 days, and so on. But in the reality is if I have one wasp or two wasps, and they make 3 wasps, and then you can have all these different combinations to get all these different offspring. And so what's going to happen is you're going to start multiplying exponentially. And so that's kind of when you know that you need to use a change of base, is when it tells you the initial value and a new value after a certain amount of time. So the first step to this problem is start identifying our key points of information. So we know that y of 30 is 50. We know we want our y of t, where we don't know what t is, to be 100. And we know we want y naught to equal 10 and n equals 30. So we're almost ready to get set up with our equation, which is y equals y naught b to the t over n. So if you start substituting things in, you get 100 equals 10, but the problem is I don't know b. And I don't know t, but t is what I'm solving for. So what you want to do is solve for b. Well, remember, we have a formula that says y naught times b is going to be y, where this y is after n amount of days. So y naught is 10, and b we don't know. And after 30 days, we're going to have 50 wasps. So again, this is using n equals 30. So if I do the math, I can get b is equal to 5. So plugging that back into my equation, I get 100 is equal to 10 times 5 to the t over 30. So 10 is equal to 5 t over 30. I take the ln of both sides. I get ln of 10 is equal to t over 30 ln of 5. I'm going to divide both sides by ln of 5. I get t over 30. So I get t is equal to 30 ln of 10 divided by ln of 5, which if you put that in a calculator, works roughly to about 42.92 days. So what you have to do is you say after how many days. So if I say 42 days, that's not enough, because after 42 days, I won't have 100 wasps. I'll have a little bit less. So you actually have to do is round up to 43 days. And so after 43 more days, you will end up with 100 wasps.